Assalamu alaikum dear students, myself Dr. Sajjad Ahmed Mir, Senior Lecturer Physics, Government Boys Higher Secondary School, Pompo. In my previous lecture, I have taught you that what will happen to a projectile which has been fired horizontally with some initial speed u. So this was the earlier my topic in my previous class, projectile fired horizontally with some initial speed from some height. Now let us go to the another kind of the projectile. So projectile fired like this. I will change now topic. So we have calculated their whole in my previous class. For that projectile we calculate time of flight, range, resultant velocity, and a few more things. What is the nature of the trajectory? Similarly, we will tackle this situation on the same way. Okay, so projectile fired at some angle. Okay, at some angle. Now it's at some angle with horizontal. Now this is at some angle with horizontal. You will enjoy this projectile motion, but once you are interested and keenly observe these lectures and try to understand what we are actually trying to convey you. Projectile fired at some angle with horizontal. Keep a notebook and a pen ready so that you will note down the things which are very essential for you. Projectile fired at some angle with horizontal, I mean x-axis. So projectile with me like this. So what you have done? You have done like this. You try to project something like this, okay, because it's making now angle, it's making angle theta with the horizontal. This is our situation. Now you project you have not even projected along vertically, neither along the horizontal direction, but at some angle with horizontal like this. What will happen? This u will get actually resolved into two components. One will be the u cos theta along the base of triangle, u cos theta. Here it will be u sin theta, okay, u sin theta component of this, u sin theta. So our projectile is under the effect of the two velocities or two speeds, u cos theta and u sin theta. U sin theta tries to actually build it up against the gravity, and the u cos theta will try to actually give the horizontal this motion to the projectile. So it will go traverse the linear distance with the help of this u cos theta component. So the projectile will under two speeds and it will go like this, and hit somewhere in the ground. Okay, so now it has been resolved in two components and it will take this path. Let us try to find out the nature of this path, as we have actually derived in a previous question the path of a projectile which were fired horizontally from some height. But now the topic is the projectile which is fired at some angle with the horizontal. Angle is here theta. So what is the nature of nature of the trajectory of a projectile? You know the trajectory of the projectile. What is trajectory? It's a path followed by the projectile. So now dear students, keenly observe what I am going to. So to determine the nature of the trajectory, we need to actually find out the relationship between the two position coordinates x and y. Only then the relationship between them gives us the clue what kind of path it will take. If suppose y is equal to mx, so then the path is straight. But it is if something else, what is the equation for ellipse, circle? If that equation turns out to be there, then from that equation we can say the nature of the job is dash dash, whatever we will get the equation. Okay, so we need to derive two displacements along x-axis and y-axis. Only then we can say the nature of the job. So we know that everyone among us, s is equal to ut plus 1/2 of at square, equation of motion, okay, for displacement. So now I will tell you along x-axis ye kya hogi, along x-axis. So along x-axis how it turns up to be. So along x-axis this becomes displacement x, because we are representing displacement along x-axis as x. This is initial velocity x, so I will give subscript to x so that it will represent initial velocity along x-axis plus half of ax, means acceleration along axis, and t square. Then you know my dear students, this x is equal to what is the initial velocity along x-axis? The initial velocity along x-axis is u cos theta. U of course sin theta, na? So u cos theta like this, u cos theta like, okay. Then this is t plus half of what is acceleration along x-axis. Since the velocity along x-axis is uniform, so therefore acceleration is 0, neglecting all other friction and etc. If we know the projectile ki jo basic definition hai, it is an object which has been thrown with some velocity and then is allowed to fall under the effect of gravity alone. So therefore in horizontal direction there is no acceleration. Acceleration is only along the vertical direction. So now here I can write down it is 0 into t square. So So x is equal to u cos theta t, then plus 0, because it turns out to be 0. So x comes out to be like this. So x is equal to u cos theta into t. This is the linear displacement covered by a projectile which has been fired at some angle with the horizontal, and that angle is theta. Okay, similarly, so what I will do, I will write down it here, x is equal to u cos theta t. Okay, write down it here, so that there we will take along y axis only. So here we will take y axis. So we x is equal to u cos theta t. Now along y axis, what will be the displacement along y axis? X axis पे तो हमने निकाली. Now we will try to derive it along y axis, because we know that s is equal to ut plus half of a square. So along y axis displacement is y. We are representing that with y. It's uyt plus half of a yt square. So this is acceleration along y axis. This is initial velocity along y axis. In our earlier case, when we take a case, there projectile fired horizontally, this time it is fired at some angle with horizontal. So this time we do have initial velocity component along y axis, that is u sin theta. Look here, u sin theta. So this y becomes u sin theta into t plus half of what is ay, acceleration along y axis, that is g. But since our projectile is here crossing two coordinates, so we need to give its direction. So we can say here minus, it's minus g. So then t square. Earlier we do have projectile in only one component, so sign was not there important, but here it is important. Okay, so minus gt square. So y is equal to u sin theta t plus into minus half of gt square, like this. Okay, this was equation along y axis, and this is equation along y axis, and earlier it was along x axis. So we want to try to build a relationship between x and y coordinates. So what is common between the two equations? It's the time. Okay, equation number 1 is here, equation number 2 is here. So the component is which common, which is time, because time is singular. It has no effect whether you are going along x axis or y axis, it will remain same, but the displacements will vary. Okay, so now what we will do, from equation first, we can write down like this: x by u cos theta is equal to t. So this t we will substitute in equation 2. So in 2 we will eliminate t. Okay, so substitute it in equation 2. Okay, हम second equation में इसको substitute कर रहे हैं. So now y is equal to u sin theta. Now in place of t we will write x by u cos theta. Then it's minus half of g, then t square. It means x by u cos theta ka whole square, like this. Have gone through it because I have just eliminated t in equation number 2. You can just look at it. So now y is equal to, we will move ahead, u sin theta. This is x by u. Okay, 1 minute. So we can cancel out this at least here. So we can write down like this. So u and u cancel like this. Okay, cut short it. Sin theta by cos theta is tangent theta. So x into tangent theta because sin theta by cosine theta is tangent theta, minus half of 2u, then cos theta, okay, write down half of g, here it is g, so g by 2, then it is x square divided by u square cos square theta. Okay, like this. We are squaring both sides. Fine. So we did squaring both sides. So my dear students, let us move ahead. So y is equal to x tangent theta, tan theta. Okay, like this. Then minus, so it is g by twice u square cos square theta into x square, like that. We are just rearranging it. Okay. So now y is equal to, now we will write down like this, tangent theta into x, because it is one of the same thing, x into tangent theta into x, it's one of the same thing. Here it is g by twice u square cos square theta into x square. Look here. So y is equal to k1x plus k2x square like this, k2x square. This is the equation. What is k? This is constant. k1 जो है टेंजेंट थीटा के बाद हमें पता है वो कांस्टेंट है, सो k1 इज इक्वल टू टेंजेंट थीटा, कांस्टेंट है. k2 जो है वो किसके बदले हैं, इट इज g डिवाइड बाई 2u स्क्वायर cos स्क्वायर थीटा, ओके, कोसाइन स्क्वायर थीटा. So g is constant, 2 is constant, u is constant, cosine theta is constant, square of that is constant. So this whole term comes out to be constant. So k1x plus k2x. So we have got the equation y is equal to k1x plus k2x square. Again, see the degree, see the power of x there is square. So this is again the equation of parabola, but second order parabola. So again we come up with the conclusion that the trajectory of projectile which has been fired at some angle with horizontal is parabolic in nature. So the conclusion of the whole thing is, I will write down conclusion here. What is conclusion? Trajectory of a projectile is okay, projectile is parabolic in nature, is parabolic in nature. Parabolic second order है ना, second order parabola, okay, second order parabolic in nature, but whatever it is second order, but it is parabolic in nature. Why? Fine. So this was the conclusion of point number 1, that in whether it has been fired horizontally, whether it has been fired at some angle with the horizontal, in both cases we have got the parabolic nature of the path. Okay, so let's stop it. We'll go to the another things. My dear students, I hope that you are keenly observing my lecture, and then go through book also, that you will understand everything there now, because the base has, you can build base here, and then many things are there which are waiting for you, so that you will go through those things. Fine. So let us move ahead and we will try to find the maximum height. So this is the maximum height, this is h max, x max, this is the maximum height. Okay, h is the maximum height, so we will write only h here. So h is maximum height. What is maximum height? It is the maximum linear distance covered by a projectile throughout its journey. Okay, throughout its journey, जो इसके सबसे ज़्यादा ना linear vertical distance cover की ना, that vertical distance is called the maximum height, because इससे ज़्यादा height नहीं आ रही है. और एक point मैं आपको बता रहा हूँ, you know what will happen अगर मैं यहाँ पर velocity निकालने की कोशिश करूँगा ना, u cos theta always remain the same, इसमें कोई फर्क नहीं पड़ती है, लेकिन u sin theta ना ये कम होता जाएगा. ठीक है, और मैं आपको एक बात बताऊँ, जो टॉप पे होगा ना, टॉप पे सिर्फ u cos थीटा होगा और u sin थीटा नहीं होगा वहाँ पर, तो यहाँ u sin थीटा के बदले 0. You know, जब आप कोई चीज़ प्रोजेक्ट ऊपर करते हो like this, it will come up, because at the top of the top point, at the maximum height, the velocity becomes 0. That vertical component becomes 0, and then onwards it will try to start get descent. Okay, first it will ascend and then it will descend. The time taken to reach at the maximum height is called the time of ascent, and then the time taken from the maximum height to the point where it strikes the ground is called time of descent. But time of ascent plus time of descent is equal to the time of flight, because time of flight is the time taken to complete the whole trajectory. Okay, so जो जहाँ पर at maximum height there is no vertical component of the velocity, u sin theta becomes 0. You must observe it, because when we throw a ball vertically upwards, it comes down, because at the peak point, at the top point, velocity becomes 0 here. But horizontal velocity is not 0. That is uniform throughout the journey, neglecting the air friction. That's the point we have neglected in the projectile motion while deriving the equations. That you need to keep into the mind. Only then you will get the correct result. Otherwise, you will go wrong. Okay. Then dear students, please go for this, how we can find this maximum height, what shall be the maximum height for a projectile, because one should know it, because if you will go for further studies, they should know it, what is the maximum height, what is the equation for it. So first of all we will go for maximum height and come up with the equation maximum height. Okay, and it is represented by h. Okay, fine, h, maximum height h. Fine. So let us try to make an equation for it. Observe it, keenly observe. See what, how can I will derive it. I am going to derive it. You know, equation of motion, v square minus u square is equal to 2as. Okay, this is the equation. Or v square is equal to u square plus 2as. This is equation. This is the equation of motion for final velocity. Okay, so now along x-axis, no, it's along y-axis, because height is along y-axis, because it's a maximum vertical distance, not horizontal. So we will take along y-axis. Along y-axis. Okay, along y-axis. So now y-axis क्या बनेगी, मैं लिखूंगा vy means final velocity along y-axis, uy means initial velocity along this y-axis, then plus twice this is ay means acceleration along y-axis, this is s के बदले हम लिखते हैं y, because the displacement along y axis. Fine, got it? So from this equation along y axis becomes this one. Now I need to actually get this maximum height equation for this. We know when this displacement, vertical displacement y becomes capital H, at that time the final velocity becomes 0, because Vy is the final velocity along the vertical, okay, vertical component. Final velocity is a vertical component, that becomes 0. So हम ऐसे लिखेंगे when or if when our y is equal to h means maximum vertical distance, then maximum पे क्या है, Vy जो है वो हमारा वहाँ पर 0 बनता है. ये मैंने पहले ही बताया आपको, vertical component becomes 0. This is Vx, this is Vy, Vx, Vy. It's going on Vy, it's going, it's because the velocity component along vertical is variable. Velocity component along horizontal remains same throughout the journey. So at the top it becomes 0. So यही मैंने बताया, it becomes 0. So here 0 square is equal to, what is the initial velocity along y axis? The initial velocity along y axis is u sin theta. U cos theta is along x axis, but u sin theta is y axis. So it is u sin theta, this is u sin theta whole square plus twice, what is acceleration along y axis? You know, along x axis there is no acceleration, but along y axis there is acceleration, that is acceleration due to gravity, that too downwards. So we will take minus g, and this is y is replaced by now h, because when y is h, then only final component along the y axis becomes 0. Okay, so this is 0 is equal to, then it is u square sin square theta, okay, because दोनों का square अलग अलग दीजिए, then plus minus twice gh. You got it, my dear students? So now we need to actually derive relation for this. So 2gh will actually shift here. 2gh is equal to u square sin square theta. So what is h? H is equal to u square sin square theta divided by 2g, okay, like this. This is the equation for maximum height. This is the equation for maximum height of the projectile which is under discussion. Which projectile? Fired at some angle with the horizontal. For that, this is maximum height. So if we know with what velocity we are launching the projectile, we can calculate the maximum height in advance. This is it. So if we will hit the 6, suppose for example, if we know how with this initial velocity we have projected and an angle is there, some angle, so we can actually determine it earlier what kind of height it is going to actually occur. Okay, fine. In advance, using this equation, h is equal to u square sin square theta divided by 2g. Fine. So now I will try to make you understand many more things here. So this is maximum height. So it's a relationship for that. We will go for other thing, okay, maximum height. Try to remember these equations, you must remember. This is the only solution, you must remember these equations. So now we will go for time of flight. We are going for time of flight. Okay, what is time of flight? It is actually represented by capital T. As I have discussed it in previous lecture, what is time of flight? It is time taken by a projectile to complete its trajectory. जो whole journey इसकी होती है ना, the whole journey it took time equal to the time of flight while it is in flight. Okay, so time of flight is that. So time of flight t we can calculate. So we know the equation, what, s is equal to ut plus half of at square. This equation of motion for displacement. Okay, now let us take it along y axis. So along y axis, look here my dear students, along y axis you can actually go for x axis as well because it is circular, but this we will take it along y axis. Along y axis, what this equation turn up to be? So this is y is equal to uyt, okay, plus half of ay t square, like this. Okay, my dear students, this is y is equal to uyt plus half of ayt square. So displacement y axis, initial velocity along y axis, this ay is the acceleration along y axis. So then y is equal to, we know initial velocity along y axis, the initial velocity along y axis is u sin theta. Okay, so this is u sin theta into t plus half of, what is acceleration along y axis? That is minus g into t square, because I have told you acceleration is only along y axis, it's not along x axis, and that too it's acting downward, so we are taking minus negative sign. So this y is equal to u sin theta into t plus minus half of gt square, like this, gt square. So my dear students, y is equal to u sin theta t plus minus half of gt square. But we are actually going to derive equation for time of flight. So what we will do, when मैं ऐसे लिखूंगा when our time, small time is any time, is equal to capital T means time of flight. Now let's make it a special case. When this time is equal to time of flight, then it has to reach here is this point. When it will reach here, the vertical displacement at this point is 0. There is no vertical displacement when it hits the ground. When it hits the ground, the projectile hits the ground, it will complete its time equal to time of flight, but at the time there will be no vertical displacement, y will be 0. So y is equal to 0, then y is equal to 0. y किसके बराबर है? It's equal to 0. So my dear students, you remember now it like this. Okay, so maximum height हमारी किसके बराबर आई? u square sin square theta divided by 2g. So now here, so substitute this when t is equal to time of flight. So y is equal to, then y is equal to 0 is equal to u sin theta into small t के बदले capital T, okay, then minus half of g capital T square, like this. My dear students, look here, when small t is capital T, y is equal to 0. So one of the t will go like this, one t. So 0 is equal to u sin theta only this, because t has taken out to be common and it becomes 0, then this minus half of g into t, okay. So it means half of g into t is equal to u sin theta. Fine. So now it means t is equal to twice u sin theta divided by g. This is the equation for time of flight. This is equation for time of flight. So I will write down here, this is maximum height, this equation for maximum height. Now time of flight comes out to be, this is twice u sin theta divided by g. This is the equation for time of flight. For what projectile? The projectile which has been fired at some angle with the horizontal. Remember it, okay. So you noted down it. So now we will go to the another thing, range, okay, range of a projectile, because this is the rhythm. So range of a projectile, what will happen to the range? So now range is equal to range. What is range? It is the maximum linear distance covered by a projectile. This is from the point where it has been projected to the point where it hits the ground. So this whole is range. This whole from here to here where it strikes the ground, this is range. Fine, my dear students. So now how do we calculate it? So we again know s is equal to ut plus half of at square, one of the equation of motion. So this time I will take it along axis, because range is along x axis, there is no other choice. So along x axis, when it's taken along x axis, our s becomes x, this is uxt, fine, this is plus half of axt square, like this. Okay, my dear students, the initial velocity along x axis, here look here, the initial velocity along x axis is u cos theta. So this becomes u cos theta into t plus half of, there is no acceleration along x axis, as I told you many a times, there is no acceleration along x axis because their velocity along x axis is constant. So this x is comes out to be u cos theta into t plus 0, okay, u cos theta into t plus 0. So x is equal to u cos theta into t. Got it? Now because I am not interested in simply x, I am interested in range. So मैं यहाँ लिखता हूँ, if you will understand, when small t is equal to capital T, what it means? It means that when time is equal to time of flight, then उस वक्त जब time of flight complete हो जाएगा ना time of flight, तब तो ये maximum linear distance निकालेगा, horizontal distance, and that too is equal to the range. So we can say at that time x becomes the range, capital R. So therefore above equations becomes like this: R is equal to u cos theta into capital T. So we can write down this like range, R is equal to u cos theta. Now u cos theta, capital T we have calculated right now, 2u sin theta by g, we have calculated it. It is 2u sin theta divided by g, okay, like this, 2u sin theta divided by g. So I will write down it here. So now range is equal to u square twice sin theta cos theta divided by g. I just rearrange the equation, but it is same, but this becomes formula twice sin theta cos theta is cosine 2 theta. So range is u square sin 2 theta divided by g. So the range is now equal to r is equal to u square sine 2 theta divided by g. You just note down these three things. We got this maximum height u square sine square theta divided by 2g, time of flight 2u sine theta by g, r is equal to u square sine 2 theta by g. Just remember these equations. If you do have any kind of doubt, just drop me a text on my message. Number is 9797012346. I repeat, 9797012346. And next I will discuss other things in the next class. Hope you will wait for that lecture. Thank you very much.